Hello students, in this video we are going to start with systematic qualitative analysis, and this is the salt number 6 which we are going to analyze. So let us begin with the preliminary test. Okay, so look at this salt. If you are going to observe, you will feel it as a amorphous salt, but what you people do is take a pinch of the salt on your fingertips. Okay, take a pinch of a salt on your fingertips and rub it like this. You can feel the crystals. So whatever salt has been given in today's experiment, it is amorphous salt, and this is pale pink in color. Even though it is looking like white color, okay, it is very pale pink. So try to recognize properly, it is a pale pink. So the color of the given salt is pale pink, and then we will go for the third preliminary test, that is solubility test. So in a small test tube we are going to take little bit of salt. To this we are going to add distilled water. After adding distilled water, shake it well. Okay. Yes, now you can see here the given salt is completely soluble in water, so the inference is going to be that salt is amorphous. Okay, so let us write it down in the notebook. Systematic qualitative analysis, salt number 6, 3 columns we are going to make: test, observation, inference, and we will begin with the preliminary test. The first was the state. The state of the given salt was crystalline. So the inference is chloride, bromide, nitrate, sulfate, Mg2 plus, aluminum 3 plus may be present. Okay, this is the inference which we have got by looking at the state. Second is color. The color of the given salt is pale pink. The pink color is very light color. Okay, so the inference is Mn2 plus may be present. Also we have conducted the solubility test. How to perform that one? Salt plus water, shake well. The observation that we got is soluble in water, so the inference is crystalline salt. Then we will go for detection of acid radical group, that is group 1, and the name of the test that we are going to perform is dilute sulfuric acid test. So what we are going to do here is, in a test tube we are going to take a small quantity of salt. To this we are going to add dilute sulfuric acid. Here you can see the reagent bottle containing the dilute sulfuric acid. So look at the observation. So you can see that after adding dilute sulfuric acid to the given salt, the observation is there is no action. We are not getting any brisk effervescence. So the observation is no action. So group 1 is absent. So we will note it down in the book. Detection of acid radical group. Group 1, dilute sulfuric acid test, salt plus dilute H2SO4. We are getting the observation as no action. So the observation is group 1, that is carbonate, CO3 2 minus is absent. So because group 1 is absent, then we will go for group 2, and the name of the test that we are going to perform is concentrated sulfuric acid test. So what we are going to do is, in a test tube again we are going to take a small quantity of salt, and to this we are going to add concentrated sulfuric acid. make sure you are going to hold the test tube with the help of a test tube holder. To this I am going to add the concentrated sulfuric acid. So look at the observation. Yes, so the observation is, after adding concentrated sulfuric acid, we are getting no action between the given salt and the concentrated sulfuric acid. So if there is no action after the addition of concentrated sulfuric acid, we are going to add the copper turnings. Okay, you can see here, there we are having the copper turnings. So to the test tube which is containing salt plus concentrated sulfuric acid, we are going to add the copper turnings. Yes, so you can see the copper turnings in the test tube. After adding copper turnings, you are going to heat it on the Bunsen flame. Yes, even after the heating we are not getting any action, we are not getting any reddish brown gas, which means it is having no action. Therefore group 2 is absent. Okay, so we have performed the test for group 2, that is concentrated H2SO4 test, salt plus drop of concentrated sulfuric acid. We got it as no action. If no action, add copper turnings and heat, which we have already done. Even after that we are getting it as no action. So the inference is group 2, that is chloride, bromide and nitrate is absent. Okay, so because group 3 is absent, we will go for the because group 2 is absent, we will go for the next group, that is group 3. So we are going for the group 3, that is test for sulfate, and we are going to perform the test by taking small quantity of salt in a given test tube, and to that we are going to add barium chloride solution. So look at the observation. Okay, you can see here we are getting the white precipitate. So the observation is white precipitate, and the inference is going to be sulfate is present. Because we are getting the group 3 present, then we will go for the confirmatory test for sulfate. So again I am taking the test tube. To this I am adding the salt, and to this we are supposed to add lead acetate. So the confirmatory test for sulfate includes salt plus lead acetate. So look at the observation which we are getting now. You can see that we are getting white precipitate, which will confirm that sulfate is present in the given salt. So group 3 test for sulfate, salt plus barium chloride solution, we are getting white precipitate. So the inference is sulfate is present. Then we will went for the confirmatory test for sulfate, salt plus lead acetate, we got white precipitate. So sulfate is confirmed. So whatever salt sample has been given in today's experiment, it contains the acid radical sulfate. So already we have detected with the acid radical. Then we will go for detection of basic radical group, and we will start with analysis of zero group radical, that is ammonium, and the test we are going to perform is salt plus NaOH solution and then boil. So I am taking a small quantity of salt in the test tube. To this I am going to add sodium hydroxide solution, NaOH, and this I am going to boil it now. Okay. Yes, after boiling I am not getting any pungent smell of ammonia, which will give the inference that zero group is absent. Okay. detection of basic radical group. We started with analysis of zero group radical ammonium, salt plus NaOH, boil. We are getting no smell of ammonia. So the inference is zero group, that is ammonium NH4 plus is absent. So this is the inference which we are getting. Then there is preparation of original solution. In short, we call it as OS. We know that in the solubility test we have came to know that the given salt is soluble in water, so the OS is prepared in water. So that we will write it down. Salt plus water, it is soluble, therefore the OS is prepared in water. Okay, then we will go for identification of group of positive radical. As I had told in the previous videos also, if there is zero group absent, we are not going to perform any test for group 1 and group 2, but we are going to write it down in the notebook, but we are not going to perform that one. If zero group is absent, then we will be going for group 3. So first we will write it down for group 1 and group 2. OS plus dilute HCl, no precipitate. Group 1 absent. Second, OS plus dilute HCl plus hydrogen sulfide, no precipitate. Group 2 absent. So whenever zero group is absent, as I told, we are not going to perform any test for group 1 and group 2. Directly we will be performing the test for group 3. Okay. So the test for group 3 that we are going to perform is, in a test tube we are going to take the original solution which we had prepared initially. Okay. I am taking the original solution in a test tube. To this we are going to add ammonium chloride. You can see the label of the reagent bottle. It is ammonium chloride. And to this we are going to add ammonium hydroxide. You can see here, add a little bit of excess of ammonium hydroxide. Okay. So after adding the ammonium hydroxide, you can see that there is no precipitate, either white precipitate or brown precipitate. So group 3 is absent. So let us write it down in the notebook. OS plus ammonium chloride plus ammonium hydroxide, no precipitate. So group 3 is absent. Because group 3 is absent, we will go for the group 4, and the test that we are supposed to perform is OS plus ammonium chloride plus ammonium hydroxide plus hydrogen sulfide. So whatever test we had conducted for group 3, only thing we are supposed to add extra is hydrogen sulfide. So whatever I have added for the group 3, for this I am going to add only the hydrogen sulfide. Look at this. This is hydrogen sulfide reagent bottle. So the observation that we are getting, you can see here, is brown precipitate. Okay. So let us write it down in the notebook. OS plus ammonium chloride plus ammonium hydroxide plus hydrogen sulfide, we are getting brown precipitate, which will give the inference that group 4 is present. Then we will go for analysis of group 4. You can see here, analysis of group 4 cation, OS plus ammonium chloride plus ammonium hydroxide, but plus hydrogen sulfide. we have already performed the test and we have got a pale brown precipitate. So the inference is in group 4 we are having two cations Zn2 plus and Mn2 plus. Because we are getting pale brown precipitate, Mn2 plus may be present. Then we will go for the confirmatory test for Mn2 plus, and how to perform is, in a test tube we are going to take original solution and we are going to add NaOH dropwise. Say I am going to take a test tube and the original solution which we have initially prepared by dissolving the given salt in water. The original solution I am taking it in a test tube. To this I am going to add NaOH, sodium hydroxide, dropwise. Add slowly. Okay, you can see the observation here. We are getting initially white precipitate which is getting turned into brown when it is exposed to air. So the observation that we are getting is white precipitate turns brown when it is exposed to air. So this will give the confirmation that in the given salt Mn2 plus is present. OS plus NaOH dropwise, we are getting white precipitate which turns brown on exposure to air. So the inference is Mn2 plus is confirmed. So the basic radical that is present in the given salt, in today's salt, is Mn2 plus and the acid radical is sulfate. So at the end we are supposed to write the report. The positive radical is Mn2 plus, the negative radical is sulfate, SO4 2 minus. Formula for the given salt is MnSO4. The name of the given compound is, because Mn is in plus 2 oxidation state, the name is manganese sulfate. So the given salt is manganese sulfate.